Hello and welcome to lesson 1-3, variables and expression. This goes with pages 13 through 15 in your book. And let's just jump right into it. Here as you go, you should have this paper in front of you for notes. And we will be copying everything down to take care of the information we need to know in this particular section. All right, right here, a branch of mathematics. This word is algebra. It's a branch of mathematics that deals with variable symbols. That's what algebra is. It's using symbols to represent numbers. Okay, well, the next word is variable. And a variable is basically a letter or a symbol. Usually for us, it will be a letter that's used to represent an unknown value. Okay, so word 3, algebraic expression. That is an expression that contains sums and or products of variables and numbers, and it can have quotients. Basically, if you have any sort of example, like say 3x plus 1, that's a very algebraic expression right there. Okay, the fourth one, this is a phrase defining a variable. Okay, so this phrase is defining a variable. To define a variable basically means to choose a variable and a quantity for the variable to represent an equation. So that might mean just saying that, hey, we're going to solve a problem that tells us how much every chocolate chip cookie costs. So x might equal the price of chocolate chip cookies. That's defining the variable, figuring out what does the variable represent, and identifying that on your paper. So when we go through the process of translating expressions, variable expressions, into a math expression from the words, we start with the words where it will describe and tell us what it is. So what you want to do is look for the most important words when you have a variable expression. All right, then you want to define the variable. Well, and you're asking yourself, well, what's the thing that I don't know? What's the unknown thing? That is the variable, the unknown quantity right there. And then you want to go ahead and translate that expression into an algebraic expression. So you want to go from a written expression to an algebraic expression. Okay, and sometimes when you do that, you might have to solve for a certain value, or they might just ask you to use the substitution property of equality. And that's basically the process of replacing a variable value in an expression in order to evaluate the expression. Okay, that's an important one there, by the way. I guess this is number 5. Substitution property of equality is basically the process of replacing the variable value in an expression in order to evaluate the expression. And here I put an example on the page for you. If x equals 5, it says evaluate 3 plus x. Well, it's a pretty simple one, but what you do is you substitute. Now, they're saying, hey, x is 5. Then you go, okay, I'll make that number a 5. And you go 3 plus 5. There, I have translated that from, I'm sorry, I have substituted the value of 5 in for the x right there. And then we would go ahead and evaluate that probably and say that its value is 8. All right, we're only at 5 minutes here, so I'm going to continue into the next part of the homework, and I doubt we'll make it through all of it. It's probably going to take another short video after this. But this is the next page that we have in your notes. And let's just jump right into it. Notice at the top it says translate each phrase into an algebraic expression. Okay, again, as I do the notes, you want to have everything down that I write down. This particular question says $4 less than, so it's a good idea to underline or circle the math words. It's less than, so something is being subtracted. Less than the cost of the sweater. Well, here's how you would define the variable. You would say S equals sweater cost. That's defining your variable right there. Tell me what it is. You might have used the letter C since it's cost, but you take the sweater cost and it says it's $4 less, S minus 4, because it's 4 less than that. So whatever the sweater costs, which was S, it's 4 less than that. So how would you do that? You would go S minus 4. Don't say 4 minus S. No, don't do that. No, that's wrong. Okay, it is not the same thing with subtraction. Can't do that. Take a look at number 2. Number 2 says 13 more students than teachers. Okay, so we're going to say, okay, well, let's let T be the teachers. So if you have 13 more students than teachers, okay, you would say T plus 13. Why did we say plus? Because you have 13 more. If I have 2 teachers, then I have 13 more students than teachers. It'd be 13 plus 2 to have 15 people there. Let's look at number 3. That says, hey, what is the money earned babysitting at $10 an hour? Okay, well, if M is the money, $10, think about per, that means multiply. Because every hour you get 10 more dollars, right? 1 hour, $10. 2 hours, 10 times 2. 3 hours, 10 times 3. So what we would say is 10M, because I've used M for it right there. So there's the answer to that question. And then the last one says 30 pencils divided among some students. All right, S would be the number of students. So if I'm going to translate that now into an algebraic phrase, I have 13 pencils divided by the number of students. And it has to be in that order. You cannot say S divided by 13. Okay, that all should be in your notes. And hopefully you're able to begin translating some of these expressions from words into algebraic expressions. And then come back for part 2, and we will look at how to evaluate and use the substitution property of equality next.